Good morning, everybody. Welcome to another exciting morning of Chem 1105 with your host, me, Dr. White. By the way, my eyes are doing good. See, when I'm doing it like this, I'm looking at myself. I'm never going to be a TV announcer because I can't look at the camera. I'm looking at my monitor. But anyways, I'm going to continue with the review for the final exam. Remember, next Monday will be the final exam. It will start at 10 a.m. A little before that, I will email you the password for your version of the final exam you should take. Don't forget tonight, if you have any last minute questions, I have my office hour. And another thing, I have this morning, I posted up to date lab scores and extra credit if you handed it in on time. If you handed anything in under the amnesty program, I should have that done by Saturday at the latest, Saturday afternoon. And by Sunday morning, I recommend all of you look at Blackboard, check that I have graded all the labs that you've handed in. If not, send me an email. And I'll also by Sunday morning post the lab total. I didn't have time this morning to send it out, but later today or tomorrow morning, I will send out an email, and attached to that will be a way to determine how many points you need to have on the final to get the grade you want. Now, there are two ways I have it calculated. One, if you've handed in all the labs, the other one, if you haven't handed in all the labs. All right. And also Friday, I will go through advice and recommendations that have helped a lot of my students how to interview to get into school, interview to get a job, which I assume you all want to do one of those two, if not both. All right, let's continue back where we left off. We've been talking about moles for test number 2 material. Again, the best way to study for my final is use your hourly exams as practice problems. Again, the best way to study for the final is to use your hourly exams as practice problems. Will I put the exact same ones on the final? No. But will I put similar ones? Of course. Just look at the regular practice problems in your hourly exams. You see the questions are similar. That's why I call them practice problems. All right. Now, there's one important problem that a lot of you have problems with, so I would definitely hint to go back and look at this, and that's what I call mass calculations for reactions. And there are 3 steps. This will be given to you, important information, final exam, which I highly recommend you take a look at. That's in the lecture set folder of Blackboard. And that's where you're asked to convert grams of one thing, compound to grams of another based on a balanced chemical equation. And there are 3 steps. Whatever you're given in mass A, you convert to moles of A. Then you convert moles of A to moles of B. And finally, you convert moles of B to grams of B. And let's look at an example of this. And if you look at number 4, thumbs up, people. Everybody see number 4 on your screen. Uh-oh, you're not seeing it. Well, in that case, all right, you should be seeing it right now. All right, everybody see number 4 on your screen? Hello? Thank you, Alyssa. All right, you're given this balanced chemical equation. And the question is, how many grams of C3H8 propane are needed to make 24.6 grams of carbon dioxide? You're trying to find carbon dioxide, grams of C3H8. You're given grams of CO2. You need 3 steps. The first step, grams of whatever you're given, CO2, you convert to moles. And we've done this. You've done this for test 2. Here's grams of CO2. You want to go to moles of CO2. Whatever you're trying to get to, it goes on top of a ratio. Whatever you trying to get rid of goes underneath. Remember, 1 mole of a compound equals its molecular weight in grams. The molecular weight of CO2, 1 carbon, 2 oxygens, 44.0. And notice grams of CO2 divided by grams of CO2 cancel out, and you're given moles of CO2. Now you have to do step 2, moles of whatever you can figure it out to moles of what you're trying to get to. Moles of CO2 to moles of C3H8 propane. Well, here's what we have, moles of CO2. We want to get to moles of propane. Use your good buddy, your good friend, unit analysis, and whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. I forgot to mention in step 1, 3 significant figures, exact number, 3 significant figures, 3 significant figure answer. Now, where do we get the ratio of moles of C3H8 to moles of CO2? From the balanced chemical equation. The balanced chemical equation gives us molar ratios. And when there's no number in front, like in C3H8, the coefficient is 1. When there's no number in front, the coefficient is 1. Ooh, I haven't done that before in a class. It's addictive. But anyways, so what this really tells us is, in this balanced equation, 1 mole of C3H8 reacts with 5 moles of oxygen to make 3 moles of CO2 and 4 moles of water. And the relationship is, for every 1 mole of C3H8 propane, we make 3 moles of CO2. And that's where you get these numbers. 1 mole of propane makes 3 moles of CO2. Now, 1 and 3, the coefficients of a balanced chemical equation, are exact numbers that play no role in determining significant figures. So this is 3, we end up with 3. Now, we have moles of C3H8, but we want to get grams of C3H8. So what do? You do step number 3. And here we go from moles of C3H8 to grams of C3H8. Again, here we have moles of propane C3H8, which we just calculated, 0.186. And we want to go to grams of C3H8. And it's time to use your good buddy, your good friend, unit analysis. You knew I had to sneak that in today. I did. And whatever you're trying to get to, grams of C3H8 goes on top of the ratio. Whatever you're trying to get rid of, moles of C3H8 go underneath. Where do we get those numbers? 1 mole of a compound equals its molecular weight in grams. And I don't have it open, so I better. Hold on. If you look at important information, final exam, I give you, and these are going to be the last 3 pages of the final exam, I give you 1 mole of a compound equals its molecular weight in grams, and the molecular weight of a compound is the sum of all atomic weights. Remember, on the final exam, like test 2, 3, and 4, it will say, please use proper significant, please use proper significant figures for all calculated answers. And it will also say, please use 3 significant figures for all atomic weights. By the way, here's, as I promised, mass calculation for reactions to 3 steps, which we're following. And now the molecular weight, 3 carbons, 8 hydrogens. Do the math, you get this, and add it up. Remember, you get the same number of significant figures to the right of the decimal as the number that has the fewest, and 0.0 is 1, 0.08 is 2, so the number of fewest is 1. So you have, keep the 0, use the 8 to round off, that becomes 44.1, put it in there, 3 significant, exact number, 3 significant, and the number is 8.20 grams. Now, as I've taught you this semester, I am a round off at each step person. And there's another group, which I don't prescribe to, but I'm not going to force you to do it my way, that rounds off only at the end. And I will calculate for the stuff on the final, each both ways. And notice I have or 8.22. And that would be if you round it off at the end, and either one would be correct. And I'd highly recommend you look at the other ones. And that's test number 2 review. And notice at the bottom I have here, remember the coefficients of balanced chemical equations are molar relations or ratios, just like I showed you in the problem we just did. All right, let's move on to test number 3 material. And first of all, we talked about gases. And a gas, you can measure what's called pressure. And there are 3 different units for measuring pressure. One is millimeters of mercury, mmHg. The other is a torr. And 1 millimeter mercury equals 1 torr. Also, and I've got this wrong, that should be, and it'll be right on the important information. Let me see if I'm telling you the truth. And notice here, I do have it correct on important information. Final exam. So anyways, and 760 mm, that should be not IN, of mercury, millimeters of mercury, or actually that should be just torr. This should be torr. I can't change it in PDF the way I have it set up. With 760 torr equals 760 millimeters of mercury equal 1 atmosphere. Also 7 Kelvin, which is what we use for what's called the gas laws, is K equals degrees C plus 273. Now there are 2 gas laws which we practiced and they were on test number 3. One is Boyle's law, P1 V1 equals P2 V2, where P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, V2 is the final volume. And here we have this equation, and generally you're going to be given 3 of these, P1, P2, what am I saying, P1, V1, I always do that, I don't know why, but, and you'll either be given P2 or V2, and you'll solve for either P2 or V2 using this equation. and go back and look at the problem set, and you'll see we did that. We have time today, I'll come back and do that. But I really want to talk about the ideal gas law. And since I haven't been subtle, I better be subtle. The ideal gas law, PV equal nRT. Know this. Really, know this. And what do you need to know? Well, if you're given a problem with a gas and nothing changes, you'll be using PV equal nRT, where P is the pressure in atmospheres, V is the volume in liters, and I'll always give you V in liters, or you'll calculate it in liters. N is the number of moles. T is the temperature in Kelvin, and R is the universal gas law constant, which is 0.0821, which is 3 significant figures, and its units are atmospheres, liters per mole Kelvin. And if we look, and let me make sure you can look, you are. If we look at number 10, if you burp, and this is going to be a monster burp, if you burp 86.75 grams of CO2 gas at 545 millimeters of mercury and 34.6 degrees C, what is the volume of your burp? Bet you never thought you get into burps in chemistry class. Well, you did. And here we have, what are we trying to find? Volume. We're given a weight, we're given a pressure, we're given a temperature, and important information, final exam, you will be given R, the universal gas law constant, 0.0821 atmospheres, liters, mole K. So what are we trying to find? Volume. If you look at this, we're dealing with a gas. It says it. And is anything changing? No. And plus 15 points. Oops, I gave that away. Shucks. But anyways, that tells you you need to use PV equal nRT. And we want to solve for volume. So how do we get rid of P pressure? Divide by that. Whatever you do to one side, you have to do to the other. And I did. And anything divided by itself is number 1 times V is V. So now we have V equal nRT divided by P. Well, P is the pressure, but it has to be in atmospheres. And we have to convert millimeters of mercury to atmospheres. And you use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top. Whatever we're trying to get rid of goes underneath. And important information, final exam, you know 1 atmosphere is 760 millimeters of mercury. These are exact numbers because this is a definition. Therefore, 3 significant figures, 3 significant figures. Temperature has to be in Kelvin. Oh no, it's in Celsius. And we have to convert it. Degree C plus 273. Degree C is 34.6. And here's the number you get. And finally, N is moles. And let me just remind you, notice important information, final exam, it tells you N has to be the number of moles. And therefore, we want to find the moles of carbon dioxide, CO2. We're given grams of CO2. We want to go to moles of CO2, and you use your good buddy, your good friend, unit analysis. Whatever you want to get to goes on top of the ratio. Whatever you want to get rid of goes underneath. Where do we get the relationship between 1 mole of a compound and a weight? And if you look at important information, final exam, back up here, I already showed it to you. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights in grams. And therefore, Zoom's being picky on me today. We need to find the molecular weight of CO2, 1 carbon, 2 oxygens. Remember, use all atomic weights. The 3 significant figures for carbon is 12.0, oxygen is 16, that's 0.0. It looks like a 6, but it's really an O. And do the math, and you add it up, and you get 44.0. And therefore, this divided by this equals this. 4 significant, exact number 3, 3 significant. If I put N, which I just calculated, in volume equals nRT divided by P, put in the moles, the universal gas law constant, temperature in Kelvin, atmospheres, I get 69.4 liters of CO2. Whoa, think about that. That's 35 2-liter bottles would be the size of that burp. Your lungs aren't that big, at least mine aren't. But notice it says both ways. Once again, when you have a multi-step calculation, you can either round off at the end or round off at each step. And I'm a each step person, but I calculated both ways for the final. And I give you some more examples you should look at. And I talked about Dalton's law of partial pressures. P total, the total pressure of a mixture of gases, is the sum of the partial pressures. You can go back and look at test number 3 for that. Next, you should be familiar with the boiling point of a liquid is when the vapor pressure of the liquid equals atmospheric pressure. Therefore, and I asked this on test number 3, the higher the altitude on Earth we go, like top of the Himalayas, the lower the atmospheric pressure, and that means the boiling point is lower. Next, I talked about solutions, and give me a second while I open up that problem set. And I talked about solution, and you should know what is a solvent and what is a solute. And a solvent is the component of a solution that's present in the greatest amount, and the solutes are the others components. And if you think about it, right now you're breathing air, and it's a solution. And what is a solvent? Nitrogen gas. It's present in the greatest amount. What's the main solute in air? Oxygen gas, which keeps us alive. Next, I talked about colloidal dispersions. An important thing to remember is it's not a solution. it's particles suspended in other liquid. And how do you know? Because it scatters light. Next, I talked about like dissolves like, and like solutes are soluble in like solvents. Polar solvents are soluble in polar solvents. Nonpolar are soluble in nonpolar. Example of polar, water. Example of nonpolar, vegetable oil, gasoline. And then I gave you some definitions. The solubility of a solute is the maximum amount of solute that will dissolve in a given amount of solvent. There are different types of solutions. Saturated, that means you've got the maximum amount of solute that can dissolve. Dilute, you just have a little bit of solute in that solution. Concentrated, you've got a lot, you're not at the maximum, but you have a lot. And remember, aqueous solution shown by the letters bracket, AQ, close bracket, means the solvent is water. Now, when it comes to solutions, how do you know and make solutions that have the consistent amount of solute and solvent? And that's called concentration. And the one I zeroed in on, you should know, hint, double hint, is molarity. And molarity is of a solution is by definition moles of solute per 1 liter of solution. However, 1 liter equals 1,000 milliliters, and this means molarity is moles of solute per 1,000 milliliters of solution. Oh, guess what? It says on your screen and mine too, very important. And know this. And once again, in this test, you had to know about 1 mole of a compound equals the molecular weight of the compound in grams, and the molecular weight is the sum of all atomic weights. Now, in molarity, again, molarity is moles of solute per 1,000 milliliters. Important problem is how many grams of that solute do I need to make a certain molar solution? And you have to do that in 2 steps. And let's take a look at an example of that. And I highly recommend you go through. And let's take a look at number 7, which I asked a similar question on test 3. And that is, what does 4.56 times 10 to the third capital M NaCl bracket AQ close bracket mean? And what is the solvent of the solution? And whenever you see capital M with a number in front and a chemical formula afterward, that means molarity, moles of solute per 1,000 milliliters of solution. And therefore, this means 4.56 times 10 cubed moles of NaCl per 1,000 milliliters. And what is the solvent? AQ tells you the solvent is water. Now, leading up to the problem I just talked about, that was 2 steps, let's look at number 8. How many moles of sodium chloride, remember, please pass the NaCl, NaCl, never mind, but anyways, are in 125 milliliters of a 3.45 capital M NaCl solution. And one of the things I've taught you all semester, and hopefully that helped you here and other classes, when you have a word problem, that's what this is. What are you being asked to find? Moles of sodium chloride. What are you given? 125 milliliters of that solution. What are you also given? 3.45 capital M NaCl sodium chloride. And what does that mean? You should know 3.45 moles of sodium chloride per 1,000 milliliters, because capital M means molarity. So I have 125 milliliters. I want to go to moles of sodium chloride. I'll use my good friend, my good buddy, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of, milliliters, go underneath. Where do I get these numbers? From the molarity. And 3, the 1,000 is an exact number, and here's the answer. Now, let's go to number 11. How many grams of sodium chloride are needed to make 3.45 milliliters of a 6.789 molar sodium chloride solution? And here, what are we trying to find? Grams of sodium chloride. What are we given? 345 milliliters of the solution, and we're given 6.789 capital M NaCl. What does that mean? Capital M molarity. 6.789 moles of sodium chloride per 1,000 milliliters. Now, there's no way I can go from milliliters to grams directly. You need two steps. And let's take a look at those two steps. First step, and before we do this, let me just show you something. If you look at an important information, final exam, under molarity, two-step problem. Step 1, we go from milliliters to moles. And step 2, we go from moles to grams. And so step 1, let me check that you should be seeing this, and you are, is milliliters to moles. So we have these many milliliters. We want to go to moles of sodium chloride. Whatever you're trying to get to when you're using your good buddy, your good friend, unit analysis goes on top. Whatever we're trying to get rid of goes underneath. And where do we get the ratio of moles of sodium chloride to milliliters? By knowing molarity is that ratio. Put it in, 3, 4 significant figures, 3 significant figures, exact number, 3 significant figures. Now I have moles of sodium chloride, but I want to get to grams of sodium chloride. So what do? I start here and say step 2, moles to grams, which we've done a couple times already, but let's do it one more time. Moles, I want to get the grams of sodium chloride. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And as you saw a couple times already this morning, important information, final exam, it says, time for some more tea. No, it doesn't. It says 1 mole of a compound equals the molecular weight of a compound, and the molecular weight is the sum of all atomic weights. And here, the molecular weight of sodium chloride, 1 sodium, 1 chloride. Remember, use all atomic weights to 3, yes, 3 significant figures, and you add it up and you get 58.5. Here I have 3, 1 is the exact number, and I get 3 significant figures. Now, once again, multi-step calculation. You can have either round off at each step, person, me, or round off at the end. And it turns out in this calculation, you get the same number both ways. And let me open up test number 4 material again. All right, everybody see test number, wrong thing, problems. That's not what I wanted. This is what I want. All right, let's look at test number 4, which you just took, but I'm going to go through it again because if you look at the point breakdown, which I already talked about, this will be on the final exam. Now, first of all, you should know what a Bronsted-Lowry acid is. That's a proton donor. A Bronsted-Lowry base is a proton acceptor. You should know that HCl, hydrochloric acid, is an acid. H2SO4, sulfuric acid, also is an acid. And finally, HNO3 is an acid. Bases you should know: sodium hydroxide, NaOH, potassium hydroxide, KOH, and ammonia, NH3. And by now, you should know that sodium chloride is a salt. Hope you know by now. And water can react with itself. This is called dissociation of water. And there's an ionization constant, which is named after me. No, not really, KW. And that's water ionization constant. K in chemistry means constant, the W is for water. And that's the hydronium ion concentration, H3O plus, equals OH minus times OH minus, and this should be 1.0 times 10 to the minus 14, which you use. Now, you should know acidic solution, hydronium ion concentration is greater than hydroxide. Basic, hydroxide is greater than hydronium, and neutral, hydroxide is equal to hydronium. And then I talked about pH. And remember, pH equals minus the log of hydronium ion concentration. And the hydronium ion concentration is equal to 1.0 times 10 to the minus x. And if this is the hydronium ion concentration, 1.0 times 10 to the minus x, you put it in here, then the pH is x. And that's my gift to you this semester, among another number of them I've given to you. And probably one of the most important things I can teach you this semester is the pH scale. pH, when the pH is 7, it's neutral. When it's above 7, it's basic. When it's below 7, it's acidic. And if you have a solution, if you have a solution of water, or actually just not a solution, what happens to the numeric value of the pH when you add acid? And what happens is the pH goes down because you're making it more acidic. And I asked that on test number 4. And what happens when you add a base? The base increases the pH because you're making it more basic. Now, buffer solutions, when you add a small amount of acid or base, resist change. Therefore, the pH doesn't change, which is what I have here. Then I taught you about titrations. When you want to titrate one thing with another, which we did in 2 labs, at neutralization, that's when the pH indicator changes color, moles of acid equals moles of base, and usually you're given 3 of these 4, both milliliters of acid and base, either molarity of acid, and you're trying to determine the molarity of base, or molarity of base, and you're trying to find the molarity of acid. On Friday, I'm going to go through a couple more, again, important information. Also on Friday, I will be going through really good tips how to do a good interview if you're trying to get into school or if you're trying to get a job, which I assume all of you will be doing at least one of those, possibly both. And that will help you. I've had students in the past, both at both schools, that's helped them get into schools like nursing at UIC Chicago, University of Illinois, Chicago. I actually, a long time ago, was a postdoctoral fellow at the Department of Chemistry at University of Illinois, Chicago. Back then we called it Circle. And I've had students get jobs that they interviewed and got home, and the hiring manager immediately called them later that night and said, you did the best interview I've ever seen. I want to offer you a job. So I highly recommend coming on Friday to hear those tips. I'm going to cut it out of the video. I don't want that floating around the internet. Got to come and take my class to find that out. Get my wrinkles out. And with that, I'm going to do something totally unusual. I'm going to let you out about 2 minutes early. And with that, I'm going to say, Gang gesund. Bye now. I'm done for today.